Hi dears, welcome to my channel. Today we are discussing class 10 fourth lesson, that is carbon and its compounds. What was the third lesson? Metal and non-metals. There I have asked you three questions. It's time to answer these questions. First one was dash is the hardest substance made of carbon. The answer is diamond. Second one, dash is the best conductor of electricity. It is silver. And the third one is name the non-metal having lustrous property. Non-metal having lustrous property is iodine. Now we are moving for the fourth lesson, that is carbon and its compounds. As we know the lesson is a little more lengthier, we are parting it into two, that is part A and part B. In part A, we are discussing bonding in carbon, versatile nature of the carbon, catenation property, tetravalency, allotropes of carbon, hydrocarbons divided into saturated and unsaturated, homologue series, functional group and nomenclature. Let's go to the class. Everyone in the nature is made of carbon. Almost every living and non-living things are having carbon in it. How the things are bonded? How the atoms are bonded within the carbon? See, what about ionic bond? Ionic bond is the one in which the sodium, and best example is sodium chloride. Here there is loss of electron from a metal and this electron is gained by the non-metal. By that way the bonding is formed. You know it. In the last class we have discussed this. For example, sodium Na 281, Cl 287, isn't it, ma? One electron from the sodium, it loses to form Na plus, and Cl gains this electron to form Cl minus. Thus, it will form Na plus Cl minus forms NaCl. Isn't it? This ionic bond, I told you also that ionic bond is a strong one. It is having high melting point, high boiling point. It also conducts electricity because of the charged nature. But what about the carbon? Is it forming bond with the ionic bond? No. It is forming bond with covalent bond. Covalent bond is the one which is formed in the carbon. See, carbon is having atomic number 6. Here 2 electrons. This is the nucleus and they are having 2 electrons in the first orbit and the second orbit containing 4 electrons. So these 4 electrons, it have to either gain 4 electron to form 2, 8 as the configuration, or it has to lose 4 electron to form 2 as the outermost shell. If carbon is forming an ionic bond, what will happen? As we know, carbon is only forming the covalent bond. But if the carbon is forming an ionic bond, the carbon has to either lose electron or gain electron. C plus, C4 plus, cation. Here, if it is losing 4 electron, it will form C4 plus cation. So, in this case, the proton will be having 6 electrons, but the outermost electron will be only 2. So, much more energy it has to be wasted to form C4 plus cation. So, it is not possible. If the carbon is gaining electron, in the other way we can assume, isn't it? C4 minus anion. If it is forming in this manner, what will happen? If it is forming in this manner, how many protons are there in the carbon? There is no change in the proton number. That is 6 only. But how many electrons will be there? 10 electrons. Assume a teacher who is managing 20 students in the class. The class will be silent, right? If the teacher is managing 70 students together, how will be the class? The teacher is not able to manage and the class will be so noisy, isn't it? In this manner it will be. So it is also practically not possible. So the carbon is not forming ionic bond. Carbon is forming this covalent bond. What is this covalent bond? Covalent means mutual sharing. Okay, during lunch time, you are having chapati. Okay, you are having chapati, you assume. And your friend bought rice with dal. Okay, chapati your mother had given with jam. But it is not good for you to eat with the jam. But if dal is there with your neighbor, you can ask from her, no? You can share. The chapati you will share with the dal from your friend. And so what will happen? So some kind of bonding will be formed. For example, hydrogen kanna. Hydrogen, what is the atomic number? 1. For making the octet, it needs 2 electrons, isn't it? Here again one more hydrogen is coming. It is also having what ma? Only 1 electron. So this hydrogen bonds with this hydrogen and forms a mutual sharing. Thus 2 electrons are common for this hydrogen as well as this hydrogen. Like you are common for your parents. You are the child of your mother. You are the child of your father. Isn't it? There is no specialty for mother and father. Both are having you as common. In this form, hydrogen, 2 hydrogen is sharing this electron. So this kind of bond is called 2 electron sharing. We are saying it as 1 electron pair. Electron pair. Pair means 2. 2 electrons are sharing. So 1 electron pair forms single bond. This is a single covalent bond formed by hydrogen. Okay. If we are moving for oxygen. Oxygen kanna. Oxygen is having 8 electrons. Oxygen 1, 2, 3, 4, 5, 6 in the outermost orbit. Again one more oxygen. 1, 2, 3, 4, 5, 6. Okay. So it needs how many electrons ma? 8 electrons should be there in total. How many are there if we are considering 1 oxygen? 1, 2, 3, 4, 5, 6. Here also 1, 2, 3, 4, 5, 6. So what will happen? These 2 oxygens are there. They will share how many electrons? 2 electrons. This oxygen will share 2 electrons and that oxygen will share 2 electrons to form how many bonds? 2 bonds. So now oxygen is having 1, 2, 3, 4, 5, 6, 7, 8. And again this oxygen is having 1, 2, 3, 4, 5, 6, 7, 8. So how many bonds will be formed? 2. Double bond. Double bond is there. We are saying it as covalent. This is also a covalent bond. Okay. In the case of nitrogen, what will be there? Nitrogen is having 1, 2, 3, 4, 5. Only 1 electron is there. There are only 5 electrons are there. Here again if nitrogen is coming 1, 2, 3, 4, 5. I am writing this electron as here. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. How many electrons are needed for it to make an octet? 3 more electrons are needed. So the nitrogen will form 1 bond, 2 bond and 3 bond. Triple bond will be formed by the nitrogen to form. These are all kind of covalent bonding. In the same way, our carbon, we are discussing carbon right now. In this way, carbon also. Carbon is having 4 electrons only in the outermost shell. So, it can either it can make bond with hydrogen. Hydrogen also to form what? Hydrocarbon. How many hydrogen will be needed? Carbon is having tetravalency. So, if hydrogen is coming 1 hydrogen, here also hydrogen, here also hydrogen, here also hydrogen. 1, 1, 1, 1. So, carbon makes 4 bonds. Single carbon can form 4 covalent bond with the hydrogen. So, we are saying carbon as tetravalent in nature. Carbon is called tetravalent in nature. Okay. Now we understood about the bonding. Now we are moving to see the versatile nature of carbon. Carbon is having something special. You know, there is a branch of chemistry called organic chemistry. Why? This organic chemistry contains mainly all the things made of carbon atoms. We are discussing about the compounds which are formed by the carbon atoms in this chemistry. There is a separate branch which deals with the atoms made by bonds or many compounds made by this carbon atom. That is the versatile nature. Why the carbon is having that much speciality? Why is the carbon so versatile in nature? Because carbon is having the speciality, that is, first one is catenation. What is this catenation? Self-linking property of the carbon is called catenation property. Here we saw hydrogen bonds with hydrogen to form H2. There it stopped, H2 only. Oxygen can form bond with oxygen to form O2, O3, that's all, isn't it? But carbon can form bond with itself to form long chain. That much long. We can't even imagine. that much compounds we can make by self-linking capacity. It is called catenation property. This is the catenation property. Self-linking capacity of the carbon. Carbon, 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 carbon. This kind of bonding it can form, and it will move as a straight line. We are saying it as straight chain of carbon atom. Only straight chain it can make? No, it can make branched chain also. Carbon, 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 here one more carbon, 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 like that it can move. It can form branched chain. Only branched chain? No. We are saying it as branched chain, Kana. It can make some other chain, that is cyclic chain. Cyclic, in a ring form it can make. Carbon, 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 carbon. This is hexagon. If see carbon, 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 carbon. Like that, some boxes, hexagon shape, pentagon shape, octagon shape, nanogon shape, any shape it can make. So it can form straight chain compounds, branched chain compounds, and cyclic compounds. It is its speciality. That's why this much compounds carbon can make. That's why it is called what? Versatile nature. No other things can make. Silicon can also make, but not to this extent. Not to this extent as carbon, nothing can make. That's why the carbon is so versatile. Okay, now we can say carbon can make only single bonds. Carbon can make double bonds also. See, carbon, double bond carbon. In this manner it can make. It can want to form triple bond also. Carbon 1, 2, 3. Carbon. This manner also it can form. Okay, we are saying the single bond as saturated and double or triple bond as unsaturated. Okay, now why all these? Because of the tetravalent nature of carbon. Carbon is see, we are having two hands, no? Carbon is having four hands. One in the front, one in the back, two in the sides. So it can, wherever it is moving, it will join, make a join. So from all the sides, it will make a join. That's why carbon is so special. Okay, because of this tetravalent nature. Tetravalent, four hands are there for carbon. From wherever the atom electron is getting, it will catch to form bond. Okay, that's the tetravalent nature. Then we are learning a new topic, that is allotropes. What is allotropes? Allotropes. Carbon can make different types of chain, different chains as I told you, but the physical properties of the carbon will be entirely different. One compound will be having entirely different properties than the other compound, but the chemical nature of it remains same, that is allotropes. Substances which are made by the carbon having different physical properties but same chemical properties are called what, ma? Allotropes. We know what? Diamond. Diamond is the one which we all wish to have, right? Your mothers will be in anniversary. If your father is gifting diamond for her, she'll be very happy, right? So diamond is that much precious for everyone. What about the coal? What about coal? Coal is a black color. It is no one like to have coal at home, right? But this diamond is also made of carbon, and this coal is also made of carbon. Graphite. Graphite is used in your pencil lead and all. This is also a form of carbon. All these. So what is the specialty of the diamond? From seeing itself, you will see there is so bright, brilliant it is. Brilliant means it's not because of this brilliancy. Brilliancy means that shining appearance is there for the diamond. It is the hardest metal. It is the one which helps to cut even glass. Diamond. So these all things, will it conduct electricity? No, it will not conduct electricity. And high melting and high boiling point for this diamond, because carbon there is bonded for other carbon in this manner. All the four valency is fulfilled by the other carbons to form such a closed bond. Right? That's why it is so hard. in the case of diamond. You know what is the chemical properties of the diamond? When we are burning the diamond in oxygen, it will release carbon dioxide. Nothing more. That is about the diamond. Now we are moving for graphite. Graphite is much more smooth compared to any other things. It is having two-dimensional formula. See, ma? Graphite. It is having sheet-like structure. Sheet-like structure it is having. See, only three sides are filled. One valency is left unfilled. So what will happen? It is having the smooth texture for this graphite, and this graphite will conduct electricity because one of the electron is free to move. So this will conduct electricity. Is it the same specialty which we are seeing for carbon? No. For this diamond? No. It is having, graphite is having low melting point, low boiling point, and all of these things are there for graphite. But when we are seeing the chemical properties, what will happen? The graphite when also burnt in air, it will give carbon dioxide. So the chemical properties of the diamond and the graphite are same, while the physical properties are entirely different. So these are called what, ma? Allotropes. While you are learning allotropes, not only diamond and graphite, you have to learn about fullerene also. Fullerene is just like our football, which is having pentagonal and hexagonal shape, and it is having some specialities, some special physical properties, but same chemical properties as we have seen in diamond as well as graphite. These are about allotropes. Now we are moving for hydrocarbon. What is this hydrocarbon? Hydrocarbon means nothing more. Carbon is having bond with hydrogen. That is hydrocarbons. As I told you, carbon is having tetravalent H, 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 H. This is the simplest form. We are saying it as methane. We are saying it as methane. M-E-T-H-A-N-E. Okay. When carbon again bonded to carbon. Carbon is bonded to carbon. Then the rest will be bonded by what, ma? This is bonded by hydrogen, 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 hydrogen. This is called what, ma? Ethane. Ethane. So, the first one is methane, only one carbon. Second one is ethane. Ethane, we are saying. Then the third one, three carbon are there, we are saying it as propane. Then 4 is there, butane. 5 is there, pentane. Like that it will be moving. Okay? You have to learn the series how we are pronouncing it. Then it will be easy for you to learn. But only is there that much to learn about the hydrocarbon? No, Kanna. Hydrocarbons are divided into saturated and unsaturated. What is that? I told you there is a glance with you are having. What is it? That means when carbon is bonded to other carbon or any other atom by single bond, we are saying it as saturated. While when the carbon is bonded with the other carbon or any other atom with double bond or triple bond, we are saying it as unsaturated. Saturated and unsaturated. As I told you before, we have seen methane, ethane, propane, butane. All these carbon was single bonded. Single bonded. We are saying it as saturated. It will be having the general formula CnH2n plus 2. Dears, we were discussing about the hydrocarbons. I told you it can be of two types, saturated as well as unsaturated. Saturated means carbon is linking to another carbon or any other atom only by single covalent bond, while unsaturated, in that carbon is linking to another carbon or any other atom in the form of double bond or triple bond. It is called unsaturated. As I told you, this saturated hydrocarbons are called alkanes. We are saying it as alkane. A-N-E, alkane. Okay. So, the first one will be CH4 because the general formula is CnH2n plus 2. Carbon is bonded to the hydrocarbon in the form CH4 to form. Okay, ma? In the case of hydrocarbons in the saturated one, carbon is connected to another carbon atom by a single bond. Second will be C, single bond C, then hydrogen, 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 hydrogen. So what will be it? C2H6. C2H6. This is called two carbon atom is, we are saying it as ethane. Ane will be continue repeating again and again. So methane, ethane, then C single bond C, single bond C. Then 1, 2, 3, 1, 2, 1, 2, 3. All these bonded to hydrogen. So it is called propane. In this manner, it is moving C3H. What will be that? 3, 4, 5, 6, 7, 8. Cn H2n plus 2 is the general formula. So we are writing it as in the form of CH4, C2H6, C3H8 like that. It is more. In the case of alkene, see ma? Ene. Here double bond is there. Carbon is linking to another carbon atom. The hydrocarbons, only carbon and hydrogen bond is there. And the carbon will be connected to hydrogen only by single bond because hydrogen is having one electron. So carbon will be bonded to another carbon atom in the form of double bond over here. Children, my throat is not proper. That's why the sound will be a little more grave. So please excuse me. Okay, dears? So the first one will not be methane. Like the methane will be formed? No, because carbon has to be bonded with another carbon. So methane like a structure is not there at all. So it starts with C double bond C, hydrogen, 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 hydrogen. It is called ethene. E-T-H-E-N-E. Ethene. C2H4. That is C and H2N is the formula. What will be the next? Next, it will be C3H2N means 6. Next will be C4H8 like that it will be moving. So it is about alkene. And the third one is alkyne. Carbon is bonded to another carbon atom in the form of triple bond. Carbon is directly bonded to another carbon. 1, 2, 3. Of these 3 electrons are shared with another carbon. So how many electrons are there as extra? Only one. It is bonded to hydrogen atom. Again one bonded to hydrogen atom. So we are saying it as ethyne. C2H2. C2H2. This is ethyne, ethyne, propyne, butane, YNE will be repeated. Is it clear, Ganna? Now we are seeing the homologous series. What is this homologous series? Series having, see ma, this is methane, this is ethane. So this carbon, this and this is having the difference of what? One carbon is extra, Ganna, and 2 hydrogen is extra. Again one carbon here and here when we are comparing, one carbon is extra and 2 hydrogen is extra. Seeing this also. C2H4, C3H6. What is extra, ma? CH2 is the extra one. CH2. Here carbon 2, here 3. So 1 carbon. Again hydrogen 4 is there. Here hydrogen 6 is there. Means 2 hydrogen is extra. That is CH. In the case of alkyne, we have seen CnH2n minus 2 is the formula. So the first common will be CH, triple bond CH. So that is C2H2, ethyne it will be. Then the next will be, how it will be, C triple bond C, then single bond C, H, 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 H. So how about it will be C3H4, C3H4. And the third one, the next will be C4H6, like that it will be moving. So we have to say here also the first and the next successive will be differ by CH2 group. Thus comes the homologous series. What is the homologous series? Series which contain groups of atoms having same chemical formula but they differ by CH2 unit. CH2 group. They are differing by, they are having similar structure and similar chemical properties, but they differ by CH2 units. So they are called homologous series. Now we are moving to next section, that is functional group. In the case of hydrocarbon, we have seen only hydrogen and carbon is bonded. But in the case of heteroatoms, unless or other than hydrogen, some other atoms may be joined because carbon has a tendency to bond with more electronegative atoms other than itself. That means it can bond with oxygen, it can bond with chlorine, fluorine, all these it can be having bond. So we are saying it as they are called functional group. What will happen when functional group is also as a part of this carbon atom? When it is joined to the carbon atom, the formula, see Makanna, simple thing, ethane, CH, single bond C, H. This is ethane, ETHANE. Here, in this case, when this hydrogen here, no, this hydrogen is replaced by OH group, we are saying it as one or functional group has been added over here. So we are saying it as ethanol, which means alcoholic group can be added to this. So what will be the specialties? The function or the chemical properties will be entirely different or much more different from the basic ethane. Ethanol is having the properties, chemical properties entirely different from that of ethane. When any functional group, not only all OH, there are many other functional groups, we are learning it in detail. See Gana, there are some functional groups which I have written. So what are these functional group called and how we have to pronounce it, all these we are learning now. It's very important part. Okay ma? First, heteroatoms. Heteroatoms, halogen family, that is chlorine, bromine, all this. Is the sound proper for you? Can you understand what I'm saying? Formula, here chlorine or bromine can be added by replacing one hydrogen with a chlorine or bromine. Okay, in this form we have to we are representing in the here one valency of this hydrogen is replaced by chlorine or bromine. We will get some other compound other than alkene. Okay, ma? And in the case of oxygen, oxygen can be in the form of OH. OH means alcoholic group. CHO means aldehyde. C double bond O means ketone. C double bond O, OH means carboxylic acid. So by this way all the hydrogen will be replaced. So by these either alcohol or aldehyde or ketone group or by carboxylic acid. So when this hydrogen is replaced by these all things, any of these things, we are saying some functional group is added to this, and this functional group will make some changes in the chemical properties. Okay ma, now we are moving to see the nomenclature, that means naming ceremony. We are going to name the carbon atom having these kinds of bonds, and how we have to name. Tindu, Mindu, all this we can't put the name ma. We have to put in the correct way based on the conditions which they are given. Okay, shall we name it? Kanna, these are the babies which are in your hand and we are moving to name it. Okay, babies means carbon compounds ka name. CH3, CH2, Cl. As I told you, one hydrogen is replaced by chlorine to form this. What is this? We don't know. That's why you are here, no? You will say. CH3, CH2 means how many carbon atoms? First, you have to number the carbon atom. How many carbon atoms are there? CH3, CH2, 2. C. 2 carbon atoms are there. So, what it will be? Methane. Ethane it will be. But chlorine is there. When heteroatom like chlorine or bromine or halogen, any halogen is added, we have to name it in the front. It should be in the prefix way. Prefix means what? In the front. Front part it should be pre-KG. Pre means before. Like the prefix. So chloro, then what is this? Ethane. It is called chloroethane. Chloro. chloroethane. Why chloroethane? Because it is having single bond, CH3C. So there is no unsaturated bonds. That's why ethane, chloroethane. Now the second one, CH3, CH2, CH2OH. First, what you have to do? You have to see how many carbon atoms are there. 1, 2, 3. So what it will be? Pro. Do you remember? Methane, ethane, propane, butane, pentane, like that it will be moving. So 1, 2, 3. So prop. Propane, can you say? N you can't say because OH group, functional group, alcoholic group. So we are saying it as prop and all. Propanol. All OH group. So we are saying it as propanol. Okay? Propanol. Then the third one is CH3, CH2, CHO. How many carbon atoms are there? 1, 2, 3. This carbon atom also you have to consider. Even though it is a functional group, it belongs to functional group, you have to consider it as the carbon atom present. So 1, 2, 3 carbon atom are there. So again propan. We can say propan. CHO means it is aldehyde. We are sounding it as all. Aldehyde starting is all, no? So propanol. What is it called? Propanol. Okay, ma? This is CH3, CH3. How many carbon atoms? 1, 2, 3. So it's again prop. C double bond O is there in between. Means it's a ketone group. So what we are saying it as propanone. ONE. Propanone. Ketone. ONE is in the end, no? The same. Propan on ONE. Here CH3, CH2, COOH. This is carboxylic acid group. But how many carbon atoms are there in together? 1, 2, 3. So prop. And it is a carboxylic group. So we are saying it as propanoic acid. What we are saying? Propanoic acid. Propanoic acid. Okay, ma? Then CH3, CH, double bond CH2. What is that? Double bond group is there. So what is that? It is ENE. It will end with ENE, right? Because I told you single bond saturated is end with ANE and double bond is end with ENE and triple bond will be end with YNE. So it is double bond only. So how many carbon atom again? 1, 2, 3. Isn't it? So propene. It is called propene. If one hydrogen is removed and one triple bond is there, what will we say? It will be propyne. All this we will say. So this is how you have to name the. Shall we write it quickly? See dears, now I have written all the names of it. It's easy for us to revise it again quickly. This is chloroethane. Okay, ma? Because 2. So chloroethane. This is 1, 2, 3. Propanol. Because OH group, alcoholic group is there. This is propanol because aldehyde group is there. This is propanone because keto group, C double bond O group is there. This is propanoic acid, COOH group is there. And triple bond C. So what is this? Propyne is there. Now nomenclature program is come to an end. Now we have to revise whether we have gone for this. Bonding in carbon atom, which kind of bond it is? Having covalent bond. Do you know the specialties of covalent bond? Covalent bond is formed, when covalent bond is formed, it is having very less energy in the intermolecular force of attraction is very less, which results in low melting and low boiling point, and it will not conduct electricity. These are the difference from the ionic bond. In the case of ionic bond, it will conduct electricity and high melting and boiling point because of the electrovalent nature of the metal and non-metal. But here the atoms are non-metals and they are not connected by the electrovalent bond, which results in the low melting as well as boiling point and will not conduct electricity. Okay, these are the important points. What is the versatile nature of carbon? There we have seen the catenation. What is that? Self-linking capacity of the carbon makes it very different. Then tetravalency. What is the carbon? Carbon is having like 4 hands which you are having in the front, back also, and in two sides. Like that, carbon is moving from where the electron is getting, if you grab. So it is having the tetravalency. Because of this, it will form bonds with carbon or any other electronegative atom also, like oxygen, nitrogen, all these, it will form bond. Then allotropic nature. Do you remember diamond? I told about diamond, graphite, and fullerenes. All these having different physical properties, but the chemical properties remains same. Then when we went for the hydrocarbons, hydrocarbons can be saturated as well as unsaturated. That means carbon-carbon single bond forms a saturated one, while carbon double bond carbon will form, or carbon triple bond carbon will form the unsaturated one. Okay. Then about the homologous series, I told you alkane, alkene, and alkyne. When they are repeated again and again with the formula, successive atoms, successive units will be differ by CH2 groups. That is called the homologous series. Then about the functional group, there are different functional group. I told you this was the thing which we were doing, because it is having aldehyde group, alcoholic group, keto group. All these will be there along with the carbon atom. When they are joined, different chemical properties it will show. And the next, the last one was nomenclature. This was the thing which we have done. Now part A is completed. Visit for